The last part of this part of the lesson relates to finding the length of the radius. Now, you may notice that this is a triangle, and it is a particular type of triangle. It is a right triangle. Therefore, to find the length of sides of right triangles, we use the Pythagorean theorem. Good. So, we have a squared plus b squared equals c squared. Okay. You know what? Instead of being random, Naya, pick a side of the triangle and tell me its length. A. So which are you making side A? BA or BC? BA. Okay. So how long is BA? 12. So there we go. 12 squared. Carla, give me a second side of the triangle, please. 8?
I mean, like, yeah.
Which side of the triangle is 8? AC. So you're saying that from here to here is AC. Is this the whole side? Is this the entire side of the triangle? No. So then it's not just 8, is it? What? Are we multiplying?
No.
What are we doing? Okay, let me ask you a different question. Okay? If I told you that x was 4, what's the length of AC? How did you do that? You add it. So let me ask you another question. What changes if I take away the 4? Nothing. Now, how do I find the length of AC? Add it. So and which side of the triangle is this? Is it the B or is it the hypotenuse? Good. Are you asking me or telling me? Why is it the hypotenuse? Excellent. So this is actually x plus 8 squared. And then by process of elimination, if this one is 12, then this one has to be x. Okay, now we're going to use the Pythagorean theorem. But first we have to expand this. So if I have x plus 8 squared, what I have is x plus 8 times x plus 8. Who remembers from algebra last year how to multiply two binomials? What method do we use, Sandra? Sandra? Raise your hand. You forgot?
Don't you, I can't remember.
Bill? FOIL method. Remember the FOIL method? Okay. FOIL method is what? What do I do first? First term. So I have x times x is x squared. Inside, so I have 8x. Outside, good. So I have another 8x. And then last, so I have 8 times 8, which is 64. So I have 12 squared plus x squared is equal to all this. I'm going to combine my like terms. So I get x squared plus 16x plus 64. So I get 12 squared. 12 squared is, we might as well figure out what that is. Thank you. 144 plus x squared. Now what do I do? Jonathan, what should I do now?
You can, like, on that backwards of x squared, you can
Why can't I add x squared and 16x? Because they're different. That's right. They're not like terms. So what do you want to subtract, Dylan?
Subtract 64.
Okay. Good. So let's subtract 64 from both sides. That gives me 80 plus x squared is equal to x squared plus 16x. Okay, now what? Subtract what, Bill? What happens when I subtract x squared from both sides? They cancel out. So that leaves me with, I have 80 over here and 16x over here. Now to solve for x, I divide both sides by 16. I get that x is equal to 5. So how long is the radius? 5. And if you think about it, it makes sense. Because we have a 5, 12, 13 right triangle. We didn't know that when we started, so it's not like, oh, of course it's a Pythagorean triple. What? Mind your way? Yeah, I'm not made out of glass.
I know my mom's like your dad was
Okay, so
Broom, shoe, broom in the shower.
what we want to know, now what we did before was we calculated the radius by using the Pythagorean theorem, but we were told that we could use the Pythagorean theorem because we were told it was a right angle. So if you went back to that last problem, you would see we had the right angle symbol. The right angle symbol is missing. So now instead of just being able to say that it's a right triangle, now what you need to do is you need to prove that it's a right triangle. So you are still using the Pythagorean theorem, but it's for a different reason. Now it's, instead of trying to figure out what the radius is, now it's to answer the question, is that a tangent? How do we know it's a tangent? We're going to know it's a tangent, and actually this is drawn poorly. We'll know it's a tangent if this is backwards. We'll know it's a tangent if we can prove that this is a right triangle. Because if we prove that it's a right triangle, then this angle, even though in my picture it doesn't look like a right angle, in fact, let me change the picture so that it makes a little more sense. There. Now, if we can prove that this is a right angle, then we can say that this line is tangent because it's perpendicular to the radius. So we're going to do the exact same thing, it's just that instead of figuring something out, we're going to answer the question. So again, we use a squared plus b squared equals c squared. This is the longest side of the triangle, so we don't know that it's a right, we don't know yet that it's a right triangle, but we still know that this is the hypotenuse. So we know that this is going to be 25 squared. Well, one of my sides is 7, the other of my sides is 24. And someone asked me, is that a Pythagorean triple? Who asked me that?
I did.
Excellent. You just saved yourself all that work.
I noticed it because the one number is off from the other side. So.
If you notice that this is a Pythagorean triple, then you know that it's a right triangle, and you know that this is a right angle, and you know that it's a tangent. But if you don't recognize, I can't stress enough the value of recognizing your Pythagorean triple. Look how much work you just saved yourself. The rest of us have to figure it out. So 7 squared is 49. 24 squared is 576. 25 squared is 625. Add 49 and 576. It's 625. 625 does in fact add up to 625. Because it's actually what we're using is the converse of the Pythagorean theorem. Remember, the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. Whereas the converse says if a squared plus b squared equals c squared, then you have a right triangle. And that's what we just proved. We proved that a squared plus b squared equals c squared. Therefore, we have a right triangle. If we have a right triangle, then therefore we have a right angle. If we have a right angle, therefore LN is perpendicular to LM. And if LM is perpendicular to LN, therefore LM is a tangent to circle N. Okay? Yes? No? What are you talking about?
I get it.
What day is it? Any other questions? Alright, so I got one more thing to go over. I want to make sure that we get to it, so time permitting, we'll practice this. Okay. What?
Where's 8 with photo?
Yes. Okay. Put on my desk. Alright, so of course in order to understand, in order to be able to do this, number one, you have to know what inscribed means. Inscribed means enclosed within. So circle O is inscribed in triangle ABC. Okay, the other thing that you need to know is the theorem that says if you have two tangent segments that share a common endpoint, then those two segments are congruent. Okay? Let me say that again. If two segments that are tangent, if two tangent segments share a common endpoint, then those two segments are congruent. Circle O. Actually, I think I wrote circle, circle. I did write circle, circle.
Wow.
I'll just write circle O. What? Yeah. No. Yes. Okay. If two tangents share an endpoint outside of the circle. What? Oh. If two tangents share an endpoint out of the circle, then those two tangents are congruent. Okay? So you have to understand that.
So,
So, what?
AE or AD and AF are 10.
Exactly.
But
Okay, let me show you by example. Jack just gave me a perfect example. The theorem says that AD is a tangent, right? And AF is a tangent, and they both share point X. Therefore, they are point A. Thank you. Therefore, they are congruent. So if AD is 10, that means that AF is also 10. Okay. So AD is congruent to AF,
so that means
and that means that DB is congruent to what?
BC.
No.
Yeah.
BE. And that CE is congruent to CN. Exactly. So if DB is 15, that means that BE is 15. And if FC is 8, then CE is 8. And now to find the perimeter, all we have to do is add up all the numbers. we get 10, 20, 20 and 30 is 50. 50 and 16 is 66. So the perimeter is 66 centimeters. Okay, it's an easy one to remember, I think. Alright, I think we'll stop. Alright, let me talk a minute about tomorrow's